Welcome back to the shop. Today we're going to turn a pile of these laptop batteries into a portable power bank with a 400 watt inverter, a USB quick charger, a power port, built-in charger for the batteries. These are the type of batteries you get out of these laptop batteries. These are 18650s. This is a BMS protection circuit for a 3-cell system, and a bunch of switches and accessories and some 3D printing. This is a receptacle for these 18650s. So what we're going to start with is building a single battery pack using a BMS, a bunch of these 18650s, as well as a pile of wire and some soldering. Once I'm done, everything is going into this box, and that's one bank. So next up, I'm gonna start soldering the 18650 case. These will fit in there. So the way these work is these cells will be in the series. So you pick whichever one is going to be your negative, positive, positive into negative, negative. So it would go negative, positive, negative, positive, negative, positive. So that's what you would have. That said, I prepared all the wires, and this project is about recycling most of the stuff that I already have laying around, so including the wire. This comes from hot end rebuilds that I've done in the past, and I guess I saved the wire, and the heater cartridge wire is what I'm using here. It's pretty stout wire, and it worked out pretty well. So what I do is I twist these on first, and I'm no expert at soldering here, but this is how I've always done it, so that's what I'm doing now. Generally for work like this, I like to use my soldering gun, and it's actually one of the reasons why I'm building this power brick. The soldering gun becomes actually portable. I should have enough power to do this. Regardless, tinning the gun, and I take some flux. I have little pieces of flux here. I put it on every terminal here. This is actually plumbing solder, which is fine. Solder is solder. And what I generally do is I melt up glob and let that glob seep in. is designed in a way, it's actually pretty self-explanatory. So this is the butt end of the first cell, 0 volts. This is the positive end of that same cell. And then on the next cell, this is the positive end. And then the cell after that, this is the positive end. So all these 4 connections. And this is your input and output, the plus and minus here. Positive and negative, obviously. This is BMS. It does charging as well as discharging. It has a 10 amp capacity peak. I believe I can run about 4 or 5 amps through this, which the cells that I'm using are not really rated for such high draw. They're more like half C rating, and to get that kind of rating throughout the whole pack, I'm gonna have to build a bunch of these. I have enough cells to build 5 of these packs and run them in parallel, including the BMSs. Once I find enough laptop batteries, I will build another 5 and run another set in parallel, so it'll be a bunch of them. So alright, so let's take the 0 volts, which is this wire goes here. That's your 0 volts, and we'll fold this like so. Alright, so after some work, these are the initial 5 packs. Eventually I'd like to put in 10 packs. So being that these are done, I also put together this ugly looking parallel connector. Actually, I have to remove that. And these are the XT60 connections. So this should theoretically give me about 20 amp hours, really, per side. So if I had 10 packs, I would have double the amperage. Regardless, this is going on the side too. Next up, we're gonna put everything inside of this ammo box. One of the nice things about these boxes is you can basically cut them with a utility knife. And what I did was I 3D printed this grill because it's going to serve as the vent for the back of this. This is going to be mounted on the inside at the bottom, and everything else is going to get mounted on top. So for me to have that, I wanted a switch for it. So I got this high amperage switch in here, and I I 3D printed, designed and 3D printed the grill. Again, I'm going to share this with whoever wants to download these. And basically, the way this works is you score it a couple of times, and eventually make yourself, you cut through the plastic. And with this grill I don't have to be too precise, because the grill is gonna cover hopefully most of my imprecision and sins. So I went ahead and drilled a bunch more holes, and as we get to assembling this thing, we'll figure, I'll show you what each one does. But this is the grill. The switch actually did not work out the way I wanted it to. I wanted to have a throw that's vertical. The switch is too wide and it's not deep enough, and it interferes with these bolts. So I turned it sideways. Still, at least it fits. Should be okay. Now I have to start doing the wiring for the actual inverter, which I cut a hole here for as well. So the inverter that I'm using, this is a 400 watt Whistler brand. I've had this for many years. I've used it on all kinds of occasions. As you can see, it's not in pristine condition, but it works well. And what I did was I cut this hole enough to not block the vents and allow me to have the front panel there. This thing doesn't have USB, doesn't have any of those things. It's just an on-off switch. The reason there's a secondary switch is because this inverter still draws power even when the switch is off. It's kind of dumb. So I don't want my batteries to go flat when I'm not using them, so I can actually turn off that. I think it should be okay, but we'll see. And the way I'm planning on attaching this inverter in the bottom, double-sided tape. I have the 3M stuff somewhere here. There it is. I figure a few strips of 3M double-sided tape directly onto this. Should be enough to hold this. And I'm planning the bottom of the battery pack. It's the bottom is not gonna have how can I say this? It's not gonna be cluttered with wires. It's gonna be an actual. There's gonna be a shield that goes over this and covers the whole bottom. So there's directional airflow there. So without further ado, let's tape this to the bottom and start the wiring. So I wanted to show you guys how it's wired in here. It's very simple, and the ground is being interrupted by this switch out here. One thing to note, being that I'm using wire, it's fairly heavy gauge, but it's not marked for polarity. I literally ran a marker through to denote the negative wire. And the way I built this is I 3D printed 3 separate pieces of plastic that fill in the whole bottom. So the small one goes first in the front, the larger one with a notch for the wire goes second, and the third one is the want to show you guys that I had to cut out a piece of this shielding to accommodate the switch in there, because I never planned for the switch to be mounted horizontally, so I had to accommodate for that. But once everything is in there, this is what the bottom looks like. It's a clean slate. The batteries will be sitting in here in this configuration. This is the first 5 cells. Printed out some of the cases for the remainder of the cells that will go in here. So all in, there's enough room for 10 cells, and I have a little bit of a corner gap here that I'm planning on using for something else. So this whole box should actually be fairly full by the time I'm done, but I have to do some more wiring before we even get to that point. Next up, let's wire the terminal posts. These are, again, keeping with the spirit of this project, these have been repurposed, recycled, so to speak. They came off of another device that is pretty much being gutted for parts. So I figured the terminal posts were very nice, so I'm gonna mount these. So at this point, we probably want to double check some of our wiring. I set the multimeter to beep. As I said, the triangles on these are the negative side. This switch, so this switch will be responsible for cutting off power to the charging system, so it doesn't backfeed to this module. I noticed that this thing actually used power even though when it was off, so I put in a switch so I can disconnect that. Again, in the interest of preserving the batteries. And the positive side looks good so far. Now I'm going to wire the switch in, and the switch is actually this buck boost converter is actually very simple to wire. Out positive, out negative, voltage in negative, voltage in positive. That's it. So I'm gonna start wiring this part. The next thing is we have to figure out a way to feed this thing power so I can charge the batteries. And they do make panel mount XT60s, but I just 3D printed this adapter over here that fits snugly over this, and I should be able to just mount it in there. I should say in there. I should be able to mount it in there from the top in. Okay folks, after this entire mess, everything is mounted, and we're gonna test it together. I have not plugged in the batteries just yet, but to explain how things work, this is the inverter switch. This cuts off the main power to the inverter switch. These are 2 battery post terminals, which I seem to have tightened like crazy. These are also recycled. This is the output switch for this DC buck converter. This is the input. This will accept anything between, I believe, 9 volts and 30. I will have to look that up and confirm down below, but I believe it's 30 volts. We have a power port here, plain power port like you would find in your car. This is the output for the 400 watt inverter, and this is a quick USB chargers with a voltmeter on there. So this is what the inside of it looks like. Let's give you a better vantage view. I tried to zip tie everything in. So this is the first pigtail. There will be, eventually there will be another one that will power, they'll get power from these 5 empty containers. There's almost no room in here. I've packed everything as tightly as I could. And before we do anything, I'd like to actually check for shorts, because even though these batteries have BMSs, this stuff doesn't like shorts. And we seem to have one. Alright, time to troubleshoot. Alright, I'm back. I went and ohmed out all of these, and it turns out one of these connections was failing. The solder failed because it was just too much mass for me to solder with small heat gun, so I had to pull out the big boy. This thing is older than I am. I think it's 250 watts, so no joke. With that said, let's see if we can hopefully keep the smoke in. It's the first. Oh boy. Second. Third bank. Things are getting toasty now. Fourth bank. And the fifth bank. This is, by my calculations, this is about 160 watt hours so far. And it's, once I'm done with this, it'll probably be in the 300 to 400 watt hour range. Let's see if it actually puts out voltage. 12.1. Let's turn on the inverter. The inverter turned on, and let's see if our soldering gun works. What do you know? It does work. As you can see, it actually drops in voltage because there's quite a bit of load. I believe this is 100 watts. It's 100 and 125. One amp, so 125 watts. Not bad. The fan is active. You can actually hear it there. And with that said, I can shut this down, and I'll show you how I'm planning on one method of charging it. So this is an old Dell power supply for a Dell laptop. Cut off the end, same old connector, plug it in. So right now, I don't know if you guys can see this. Can you guys see this? I'm not sure. Now I've turned it on. It's charging at 2.4 amps. This thing will do up to 50 watts, so it'll do up to 4 amps as needed. The batteries are not flat in this, but I'm a happy guy. I'm planning on making another cable like this. It has alligator clips. I can clamp onto another battery, or better yet, a solar system. These are now actually called, what do they call them? They call them solar generators, which is basically a battery bank, and that's what I'm gonna label it as on my video. Hopefully this video isn't too long. And if you guys want to build one just like this, I have gone ahead and looked up a bunch of Amazon links. These links are affiliate links, so if by using them you give me a couple of bucks. If not, research your own. For the most part, I've given you everything that I've done here, and I'm quite happy with this thing. I can turn off the voltmeter, and it's already dropped from 2.5 amps to 700 milliamp hours. One of the nice things about the buck converter is you can limit the current you want to put in, but I have enough cells in parallel that I can actually dump the full 4 amps in there, and it would be okay. Because you're dividing 4 amps by 5, so whatever the heck that works out to. Either way, I'm happy with the results, and I'm quite happy with this thing. I should also be able to jump start cars with this if I ever wanted to. Literally unscrew the posts, clamp on jumper leads, and I should have 12.24 volts right now, so I'm climbing. And either way, thank you for watching, and I'll see you guys next time.